Hello, dear student. How are you? I hope you are will be fine. I'm also fine. Thank you. Welcome to our channel. Let's start today's topic. Today is lecture number 4 of nucleophilic substitution reaction. And today lecture we will be studying one another factor that affect the strength of nucleophilicity, the strength of nucleophile NSN2 reaction or in nucleophilic substitution reaction or in bimolecular substitution reaction. What is the effect of solvent? What is the effect of solvent? Effect of effect of solvent on nucleophile. Effect of solvent on nucleophile in SN2 reaction. What will be the effect of solvent? First of all, you should know that what is the types of solvent. There are two types of solvents. There are two types of solvents. Two types of solvent. One is polar solvent, another is non-polar solvent. One is polar solvent, and one is non-polar solvent. Non-polar solvent. What is polar solvent? Polar solvent are those solvents in which poles can be formed, in which dipole, in which two poles are present, which are dipoles. Dipole mean two different poles are present. Dipole mean in which two poles, that is positive and negative pole, positive and negative both poles are present, will be called polar solvent. While those solvents in which the molecule or the atoms, in which the molecules, in which the atom and the molecule of the solvents, all the atoms are have same electronegativity, almost same electronegativity. Like this is CH4, CH4, or you can write that when benzene. In benzene, here is all in benzene, here is all C6H6, all his hydrogen carbon has 2.5 electronegativity, hydrogen is 2.1 electronegativity, almost this is same energy, same electronegativity. That's why the pole cannot be formed like in another compounds, like N2, that is gas, N2, that is Cl2. These all molecules, are these all atoms are polar. So the solvents that have no pole, no, that are not dipole, but the dipole, the solvent that are dipole, their molecules are dipole, that will be called polar solvent. Or the solvent, their molecules are not dipole, in which all the sorry, the solvents in which the molecules are not dipole will be called non-polar solvents. So these are polar solvent and non-polar solvents. Nucleophile will be act as a good nucleophile will be are those nucleophile that are in polar solvents. In polar solvent, the nucleophile will be good nucleophile, while in non-polar solvents, the nucleophilicity will be decreased when there is same nucleophile that is placed in either polar solvent or in non-polar solvent. So the nucleophile will be act as a good nucleophile in polar solvents, but not be in non-polar solvent, because in non-polar solvents, they cannot be dissolved, they cannot be solvated. Like there is one molecule, let's suppose there is KOH. In case of KOH, when they dissolve in when they dissociated in non-polar solvents, they will be K plus OH negative, K plus OH negative. So here the not the K plus, not the OH, and either even not be anyone dissociated, even not be anyone solvated. So that's why they can be react each other again. But in polar solvents, the one will be solvated, each one will be solvated. But there are two another types, there are two further types, further classification of polar solvents. So that's why one polar solvent will be like as a will be like, in one solvent the nucleophile will be act as a good nucleophile, while in another solvent there will be act as a weak nucleophile. The one polar solvent is called protic solvent, while the another solvent is called aprotic solvent. So what is the difference between protic solvent and aprotic solvents? The solvents, the nucleophile in aprotic solvent will be act as a good nucleophile, while the nucleophile in protic solvent will not be act as a good nucleophile. So let's explain that. Yeah, polar solvents. What is polar solvent? Polar solvent, when they will be also have two types: protic solvent and aprotic solvent. Protic solvent and aprotic solvent. Aprotic solvent. Yeah, there are two types. Protic solvent are those solvents, those polar solvents in which OH NH bond present. OH NH bond present. So that's why, because of this bond, the hydrogen bond can be possible, hydrogen bond can be present. But aprotic solvents are those solvents in which in which the molecules of the solvent cannot have OH and or NH bonds. So that's why these molecules cannot form the hydrogen bond. So the protic solvent will be, the salvation power of protic solvent will be more as compared to the aprotic solvent, because of the capacity of protic hydrogen bonding. It is due to hydrogen bonding formation will be occur. Hydrogen bonding can be formed by aprotic solvents, so hydrogen bond cannot be produced. So in this case, why in protic solvents the nucleophile will be act as a good nucleophile? In protic solvent, nucleophile will be act as a good nucleophile because in protic solvent, like when there is KF solute, why you use the fluoride ion as a nucleophile. So when you use protic solvent and when you use aprotic solvent, what will be the effects on the nucleophile? The effect will be like that: when you use the protic solvent and protic solvent, the effect will be like that. Let's suppose you use the water H2O, or you use the ether, alcohol, you use alcohol, yeah, sorry, not ether. When you use alcohol, what will be happen? It will be like that. The water will be like that. It will be like that. That is the fluoride ion, and that is chloride, that is K. So K plus fluoride negative. The fluoride negative will be like that. That is HOR. So hydrogen bonding will be produced between the hydrogen of the solvent, hydrogen of the protic solvent, and the negative species, that is fluoride ion. So the bonding will be produced. It means that the fluoride ion will be solvated, and it will show less reactivity to the carbon. It will show less reactivity to the electrophile or to the carbon, electrophilic carbon. It means that will show that in this solvent, in protic solvent, fluoride ion will act as this nucleophile will act as a poor nucleophile or weak nucleophile. But in aprotic solvent, like there is acetone, ketone, CH3, double bond O, CH3, ketone. Or in case of acetonitrile, CH3, triple bond N. In acetonitrile, there is no OH or NH bond present, so that's why here cannot be produce hydrogen bonding. Hydrogen bonding effect here is negligible. Here is zero hydrogen bonding effect. So that's why when you use these the KF, when you use a aprotic solvent, which is called 18 crown 6 ether, which is called 18 crown 6 ether. Yeah, this is the compound. This is like the structure of this compound is that OO So yeah, this is the structure of the 18 crown 6 ether. So in this structure, let's suppose when you use Kf, so here the potassium plus will be completely dissociated by this ion. When they are completely dissociated in the solvent, in the solution, only fluoride ion will be remaining, where where no salvation, the fluoride ion are be completely free. So that's why they will be act as a good nucleophile, and they will attack an electrophile very best. They will be attack an electrophilic carbon very good. So that's why in aprotic solvent in aprotic solvent, the nucleophile will be act as a good nucleophile, and while in protic solvent the nucleophile will be act as a poor nucleophile. So electro solvents also affect on the nucleophilicity, on the strength of nucleophile. I hope this point will be clear. If you have any question, if you have any confusion, you can ask me in comment section, or you can also ask me in my personal words or Gmail that I put in description box. You can get from there. Please support my channel, support me to subscribe my channel. It help me, it make me feel happy that my students are supporting me. Okay, thank you. Very best of luck, my dear student. Very best of luck.